Just about overview. Yes, today we'll continue for that. So first, big data. What is big data? Yesterday we have discussed. So just I'm repeating yesterday's class. After repeating yesterday's class, then I'll go to new topic. Yes, big data. What is big data? Yes, our syllabus. What are the topics going to cover in our syllabus? Yes, big data and Hadoop. Our topic is big data and Hadoop. So as a part of this course, first of all, I'm going to explain about big data concepts, all big data concepts. After finishing big data concepts, next Hadoop core modules. Next topic is Hadoop core modules. Hadoop core modules. Yes, in core modules, first one is HDFS, second one MapReduce, HDFS and MapReduce. Yes, after finishing this, next third topic is Hadoop ecosystems. Hadoop ecosystems. Hadoop ecosystems. Yes, in ecosystems, first one is Hive, second one is Scoop. Second one is Scoop. Yes, third one is Pig. So first one is Hive, next is Scoop, next Pig. Yes, after finishing this one, next Flume. Yes, next yes, Zookeeper. Next topic is Zookeeper. Yes, next sixth topic is Woozy. Okay, Hive, Scoop, Pig, Flume, Zookeeper. Next Woozy. Next seventh one is HBase. So these are the topics going to discuss in our complete syllabus. Okay, in our complete syllabus, these are the topics we will discuss. So here first big data concepts, next Hadoop core modules in this HDFS and MapReduce, next Hadoop ecosystems, Hive, Scoop, Pig, Flume, Zookeeper, Woozy, and HBase. These 7 ecosystems going to discuss. Okay, core modules, these 2 modules, and these 7 total 9 modules we are going to discuss. Right? Okay. Yes, let us start. Is big data. First big data concepts. Yesterday we have discussed just a little bit. I am repeating yesterday topic, same review. Just so let us review the yesterday topic. Okay, just I am reviewing the yesterday topic. Okay, yes, big data concepts. So first point is big data concepts here. So what are the big data concepts? Yes, yes, someone asking doubts. 1 second, let me check it. No, I will check it. Yes, I'll check it and tell you. Yes, I think may not be myself. This is somebody. Okay. Yes, big data concepts. Yes, what are the big data concepts? Let us see. Let us see all the big data concepts. Okay. Yes, yesterday already we have discussed about big data concepts. Still, I'm repeating the topic because somebody yes came new. Some new attendees for today. Yes, for them, for the purpose of new members, I'm repeating yesterday topic. Okay. Yes, big data concepts. In big data concepts, so first of all, what is big data? First question is, what is big data? Everyone nowadays talking about big data. What is big data? What is big data? Okay, so first point is, what is big data? Just a minute, I'll be back. Just a minute. Yes. So what is big data? First point, yes, what is big data? First question is, what is big data? Yes, in market nowadays, everyone talking about big data. Exactly what is big data? Yes, yesterday we have discussed about big data. Yes, of course, I'm repeating. Okay, today also just repeating because some new members are there. For the purpose of new members, I am repeating this topic. What is big data? See, for example, let us take some company. Okay, suppose I have some company, for example, my company. I have some company. Okay, yes, company, yes, having storage capacity. Yes, data storage having storage, data storage capacity, capacity of 100 TB. Just assume that. Okay, 100 TB. Yes, maybe 100 TB. Yes, maybe 1000 TB. Maybe 100 petabytes. Something like this. Okay. Yes, I have a company. Yes, I have some company here. Yes, I have some company. Yes, which is having data storage capacity of 100 bytes. Okay, so this is current capacity of data storage, right? Okay. Yes, in my company, everyday transactions, everyday all the transactions happening, right? Yes, for every transaction, some data generates. That data has to store in some database, right? Okay, like this, all the transactions storing database. Suppose my company started long back, maybe 10 years back started. Okay, that time, yes, storage capacity. Yes, initially storage capacity is 100 TB that time. Okay, yes, business is growing, right? So as long as business is growing here, yes, data also increases, right? Okay, business growing, transactions increases, right? Okay, so whenever transactions increasing, business growing here, automatically data also growing, right? Okay, yes, so maybe at some particular point of time, at particular point of time here, this 100 TB may not be enough. This storage capacity, this capacity may not be enough. Okay, yes, because of many number of transactions, huge number of transactions happening every day. So because of many number of transactions happening in company here, this capacity may not be enough. 100 TB capacity may not be enough. That means incoming data is more than the capacity of my servers. Okay, so the capacity of my servers is only 100 TB, but incoming data, so incoming data is more than the capacity of the servers. Okay, that data is called as big data. Okay, that data is called as big data. If incoming data is more than the capacity of servers here, that is called as big data. Okay, right? Yes, that incoming data, maybe any data, any amount of data, any amount of, yes, any amount of data, any amount of data, maybe 1 TB data, maybe 2 TB data, maybe 100 TB data, maybe petabytes of data, any amount of data which is okay, so any amount of data which is more than, yes, which is more than storage capacity, which is more than storage capacity, which is more than storage capacity. Okay, any amount of data which is more than storage capacity, okay, called as big data. That is called as big data. Big data, right? So you can any amount of whatever data getting here, incoming data, okay, any amount of data which is more than storage capacity, okay, any amount of data which is more than storage capacity called as big data. Big data, right? Okay, yes, beyond of storage limit. Okay, so any amount of data which is beyond of storage limit, beyond of our storage limit, beyond beyond of, yes, beyond of our storage limit. Okay, storage limit called as big data here, right? Okay, so any amount of data which is beyond of storage limit. Okay, so which is beyond of our storage limit called as big data, right? I think you understand, right? This is big data definition. So what is big data? What is big data? Any amount of data which is coming, yes, which is coming here, right? Any amount of data which is beyond of our storage limit. Okay, yes, incoming data which is beyond of storage limit, that is called as big data. This is about big data, simple definition. Okay, this definition you can apply anywhere. Okay, suppose for example here, take Facebook. Facebook is having some storage capacity, right? But incoming data is more than the its capacity, right? That data is called as big data. That data is called as big data, right? Okay. Yes, you take anyone, Google. Yes, let us take some Google. Okay, Google. Okay, or yes, you take Amazon. You take anyone, any company, right? Yes, currently maybe having some certain storage capacity, right? Currently having some storage capacity, but incoming data may be more than the storage capacity, right? That is called as big data. Okay, maybe Facebook, maybe yes, Google, yes, maybe Google search engine, yes, maybe yes, online shopping, Flipkart, Amazon, so whatever it is here, maybe Facebook, okay, maybe Instagram, okay, maybe WhatsApp, whatever it is here. If incoming data is more than their storage capacity, they might be facing big data problem, right? Okay, so they might be facing big data problem. Okay, so initially Google has faced big data problem. Okay, yes, in 2004, yes, in the year 2004, Google has faced big data problem. Okay, first problem faced by the Google in the year 2004. Yes, Google has faced big data problem. So Google has faced yes, big data problem. Google has faced first Google in 2004. First Google has faced big data problem. Okay, to overcome that, started development of Hadoop. Okay, that history we'll discuss later. Okay, Hadoop history we'll discuss later. Okay, yes, initially in 2004, in the year 2004, Google has faced the first time big data problem. Okay, yes, in the year 2004, or in the year 2004, Google, yes, in the Google, yes, incoming data. Okay, many number of searches, millions of searches happening in 2004. The data, incoming data is more than the capacity of the servers. Okay, they faced big data problem in the year 2004, right? Okay, yes. So initially 2004, in 2004, Google has faced big data problem. So this is big data definition. Okay, so what is big data? Any amount of data which is beyond of their storage capacity. Yes, if incoming data is more than the storage capacity, then facing big data problem, right? That is called as big data, right? Okay, yes, so this is definition of big data, right? Okay, next, let us see some more examples of big data here. Yes, what are the sources of big data? What are the sources? Some sources. Okay, so what are the sources of big data? Okay, what are the sources of big data? Okay, what are the sources of big data? Let us see one by one. Sources. So big data sources. Okay, yes, yesterday of course discussed. Still I am repeating the topic because some new members are there. For the purpose of new members, I am repeating same topic again. Okay, yes, so what are the sources of big data? Let us see sources of big data. Okay, yes, here sources of big data. What are the sources of big data? Yes, yesterday we have discussed some examples, right? Okay, yes, big data. Best example. Best example. Yes, historical data. Historical data. Historical data comes under big data. Best example is historical data. Sources of big data. Best example is historical data. Yes, let us see what is historical data. Okay, yes, historical data. There are two things in this: historical historical data, and transactional data. Historical data and transactional, yes, transactional data. Yes, what is historical data? What is transactional data? Let us see that. See here, transactional data means, so whatever data generating every day. Okay, so transactional data is nothing but it's a daily data. Okay, everyday data here. It's a daily data. Okay, daily some data generating, right? So daily data is called a transactional data. Okay, yes, transaction every day some data generating, right? Every day some transactions happening, right? That is called as everyday transactions happening here. Okay, yeah, that is the transactional data. Okay, yes, I will tell you exactly what's the difference here. What's the historical data, transactional data? What's the difference between these two here? Suppose this year, yes, 2019, right? This year is 2019. Okay, 2019. Okay, next year is 2010, right? Okay, yes, this financial year. Yes, yeah, as per ESA, December 31st is the financial year. Okay, ESA, yes, ESA, yes, in ESA, December 31st is the Yes, end of the financial year, right? Yes, if it is India, of course, March 31st. Okay, so but December 31st, as per ESA, December 31st is the end of the year closing, right? Okay, suppose if it is India, yes, as per India, yes, it is, yes, it is, yes, 31st March, 31st March, right? 31st March. Okay, 31st March. Okay, so as per ESA, yes, it's a 31st December. Okay, so as per India, it's a 31st March, right? Okay, yes, year closing. Yes, year closing 31st December or 31st March, right? Okay, yes. So once year closed, so once balance sheet submitted, closing year. Okay, so for the, yes, for the purpose of closing year, they will submit the balance sheet. Okay, balance sheet. So once the balance sheet submitted here, close, they will close the year, right? So once the balance sheet submitted till the date, what are the transactions happen here, the data comes under historical data. Okay, current year data, running data is a transactional data, current year data is a transactional data, current year data is a transactional data. Once the balance sheet submitted, closing year, right? So once that financial year closed, so once financial year closed here, that data comes under historical data. Okay, once a financial year, yes, once year is closed, so once balance sheet submitted, once balance sheet submitted, closing that year, right? So once year is closed, once year is closed here, so whatever the transactions in that year, the transaction, the data becomes as a historical data. So once year is closed, once year is closed, the data becomes, yes, historical data, right? Okay, so before closing the year, whatever data is generating is a transactional data. That's a difference here, transactional data and historical data, right? Transactional data and historical data difference is that. Okay, so transactional data means daily data, so whatever data is generating every day. Okay, so whatever the data is generating every day, that data is called transactional data. So daily data is called as transactional data. Daily data is a transactional data. Okay, every day some transactions happening, right? That is called transactional data. Next, at the end of year, at the end of year closing, right? Yes, it for 31st December, yes, India 31st March, right? Year closing. Okay, so once year closed, so once year closed, the data comes under historical, the data goes to historical data. Okay, so once year closed, once the financial year closed here, once balance sheet submitted, once balance sheet submitted here, that data can, that data is a historical data. Okay, see, historical data cannot be modified, but we can modify the transactional data, transaction data. So but daily some transactions happening, right? That records you can modify it. Okay, yes, we can modify that records, what is happening, transactions here, that records can be, yes, modified. Transactional data can be updated, it can be modified, but historical data should not be modified. Okay, so once year closed, yes, once year closed, the data should not be modified. Okay, historical data cannot be modified, but transactional data can be modified. Okay, so you can before, yes, before submitting balance sheet, before submitting, yes, balance sheet, they'll make some adjustment, right? The company will make some adjustments. For the purpose of adjustments here, for the purpose of adjustments, they will modify some data. After modification of modification of data, then they will submit the balance sheet. Yes, balance sheet, yes, that, yes, that incoming and outgoing both has to both has to match, right? Yes, credit and debit transactions in balance sheet, credit and debit, the transactions has to match. Okay, yes, once matched here, they'll submit the balance sheet. So once the balance sheet submitted here, that data comes under historical data, that is called as historical data. Okay, yes, yes, how we, yes, question is how we convert transactional data into historical data. You see, once balance sheet submitted, once balance sheet is submitted here, that data comes under historical data. Okay, so once data becomes historical data here, they will log the data, company will log the data. So once logged with that data here, nobody can modify it. Okay, only read only. Okay, so the database admin, DB admin guy will give the only read only permission. Okay, yes, they can't give update permission here. They will close the update permissions, they will close the permissions, so nobody can modify it. Only they can read the data here. That is a way to convert from transactional data to historical data. Okay, just simply they will log the tables, only read only. Okay, the DBA database administrator, they'll be the only read only permissions. Okay, yes, they can't they will not allow, to modify the data here. They'll remove all the permissions on database, only giving read only permissions, that's it here. Okay, so by the way of giving only read only permissions, they will log the data. Nobody can touch that data here. We can read that data, we can read, but we cannot modify here. So in that way, they will convert transactional data into historical data. Once balance sheet submitted here, transactional data converts into historical data, right? Okay, so that is about historical data and transactional data. Yeah, this is most important point in Hadoop. Okay, yeah, this is some basic question. Yes, in big data. Okay, it's an interview question compulsory. Yes, can you differentiate historical data and transactional data? What's the difference between this? Maybe asking this question. This is one of the important point. Okay, in big data. Okay, so historical data and transactional data, right? So this is one of the examples of big data. See, historical data, how it's a big data. Let us see that. How it's a big data. Okay, see, suppose here, see, any company, any company will have the servers of storage capacity for 3 years. 3 years of transactions only here. Only 3 years of transactions. Any company will maintain. Yes, of course, some companies maintain some. Yes, maybe 5 years later, 5 years transactions also. Reason is, yes, if it is expensive. Yes, if it is 5 years means expensive. Okay, any company, yes, any company for 3 years of transactions, they will have the storage capacity. So any company storage capacity. Yes, yeah, fine. Yes, transaction data. Yes, yes, someone is asking out. Yes, transaction data is a day-to-day. Yes, daily data, day-to-day activities, day-to-day activities. Yeah, exactly right. Day-to-day activities are transactional data. Okay, that can be modified. Okay, that can be modified. Yes, for example, here how it is modification sometimes here. Suppose, for example, in online if you purchase, right? Suppose in online, yes, you purchase some item, right? Okay, after delivering, suppose some damage for the item, right? So we'll return back it, right? So once return back it here, what happens here? They will update the data, right? They will modify data, right? Okay, some items will be damaged items, right? So replacing purpose means, yes, once replaced here, what happens? They will update, they will modify data. So it's a that is transaction. The transactional data can be modified. Okay, right? Yes, yes, here. So generally here historical data, yes, here I'm talking about historical data. Historical data is one of the big data examples, right? Yes, how it is. Okay, how, what's the reason behind of this? See, any company, take any company here, any company, any company, yes, yes, any company storage capacity. Yes, any company storage capacity for only 3 years of transaction, for only 3 years. Suppose, of course, some companies maybe 5 years of transactions also. Yes, any company storage capacity, yes, for only 3 years of transactions. Okay, 3 years of last 3 years of transactions, they will maintain this. Yes, best example, banking system. Suppose in banking system, one second, someone is asking out. Yet traditional databases we can use for the historical data as well as transactional data also. Traditional databases we can use for the historical data as well as transactional data also. Okay, yes, that's what I'm saying. Now our point is same. Yes, storage capacity, 3 years of transactions, 3 years of transactions. Suppose some companies having 3 years of transaction storage capacity, that means, so current year, apart from current year, previous 2 years, right? Totally 3 years of transaction. Previous 2 years is a historical data. Current year data is a transactional data. So historical data as a transaction, both they will maintain both here, right? Okay. Yes, more than 3 years data is more than 3 years. What happens here? They will move into Hadoop. Yes, maybe facing, yes, taking backup. So storage in the form of backups. Yes, every year data they will maintain backups. Yes, all the backups storage in another location, right? Okay. So here, yes, any company storage capacity only for 3 years, last 3 years of data. Yes, best example, I'll tell you one best example. You take banking system, take banking system. Yes, if you want statement, suppose if you statement request, when you submit a request for a statement, suppose 3 years, suppose for example 3 months of statement, immediately, yes, immediately you'll get it, right? Okay, once you submitted 3 years, so immediately you'll getting it. So three, sorry, yes, 1 month statement immediately getting, 3 month statement also immediately getting, suppose 6 month statement also immediately getting. But if you want 3 years of statements, they can't give immediately. They will take 24 hours of time care. Okay, they will give 24 hours of time care. After 24 hours, they will provide it. So reason is, okay, reason is up to 3 years of data, they will maintain this. 3 years of last 3 years of data is live data. Remaining all data in the form of backup. In the form of backup. Okay, remaining all data in the form of backup here. That is not a live data, that is offline data, that is not a online data. Last 3 years of data is a online data. It's a online data, it's a live data. Every company last 3 years of data is a live data. Live data. Remaining all data in the offline data, they will maintain in the form of backups. Okay, right? Suppose if it is last 3 years of statement, bank can provide immediately because it's a live data. Okay, more than 3 years. If any customer is asking for more than 3 years here, yeah, they will take some time here, 24 hours time, right? Okay, so what happens here? They will get the statement from the backup data. Yes, after getting statement from the backup data, they will provide for you. Okay, so you can live servers will maintain only 3 years of data. Of course, some companies maybe 5 years of data also. It depends on the companies. Okay, some companies maybe 5 years of data also maintain this is remaining all in the form of backup. Okay, suppose let us take some example. Suppose some company started in the year 2000. Some company started in the year 2000 here. Okay, yes, company started, some company started in the year, yes, in the year 2000, in the year 2000. Okay, some company started, yes, in the year 2000. Okay, yes, 2000 year generating some data. Okay, right? Yes, they will take backup and maintaining the form of backup. Next 2001. Okay, next 2002. Yes, like this up to 2000. Yes, yes, 2019, right? Okay, yes, 2001, 2002, 3, 4, 5, 6, 7, 8, 9, 2010, 2011, 2012. Yes, up to 2019, like this data. Okay, okay, okay. Yes, 2019. Of course, 2019. Yes, 31st December. Yes, closing 2019 data, right? Okay, so that means up to 2018. Yes, is a historical data. Up to 2018 is a historical data. Current running data is 2019. 31st December year closing, right? Year closing. Okay, see this here 2018, right? So this is total thing is historical data. Okay, yes, now here suppose that company capacity only, yes, company capacity of storage. Yes, storage capacity storage capacity storage capacity only 3 years data. Storage capacity is only 3 years data. Okay, storing 3 years of data, right? Okay, see all the data in the form of backups. Yes, 2000, 2001, 2002, like this, all this data in the form of backups. Okay, every day, yes, every month daily backups, sometimes daily backups, weekly backups. Yeah, this is called as something. Daily backup is incremental backup. Yes, weekly backup is a fully backup. Yes, incremental backup and fully backup. What is incremental backup? Fully backup we'll discuss. I will explain. Just wait for this. Yes, yes, you have to learn a lot of terminology in this. Okay, we'll discuss all the terminology. I will explain every terminology. Okay, so what is incremental backup? What is yes, fully backup? We'll discuss later. Okay, right? Yes. Yeah, 1 second. Yeah, Vasdev. Yes, your doubts. Yes, backup data in the cloud. Yes, what's the purpose of cloud? That also we'll discuss. Wait. Okay, where to store that backup data? That also we'll discuss. Wait for some time. Okay. Now let me finish our topic actually. Okay. Yes. So backup data up to 2018. Yes, all years are backup data. 2019 is a transactional data, right? Okay. Suppose some company storage capacity only 3 years of data. 3 years of data means last 3 years means 2019 year, previous year 2018, previous is 2017, right? Now these 3 years of data is live data. Live data. Okay, these 3 years 2019, 2018, 2017, these 3 years is a live data. Okay, these are inside the server, live servers, right? Okay, so anyone wanted about these transactions, they can read immediately. 2019 transaction they can see immediately, 2018 also they can see, 2017 also they can see, right? Yes, we can see these 3 years of data immediately because these are in live, but remaining data is not in live. Okay, now requirements. Yes, requirement is, yes, yes, let us see some requirement for the company. Okay, requirement. What is requirement here? Yes, company, yes, wanted to analyze their business. Company wanted to analyze their business. Okay, analyze their business. How they can analyze their business? Yes, business analysis very important. Okay, in this competitive market here, business analysis is very important. How they can analyze the business here? What's the purpose of business analysis here? Okay, yes, to improve their business. Yes, that business has to grow every day, right? Okay, so to improve their business they should analyze the business. They should analyze this business analysis. Without business analysis they can't improve their business. Okay, business has to increase day by day, right? So for this purpose they should analyze this. So what kind of analysis here? What kind of analysis? Like suppose last year how many transactions, before last year what are the transactions here, previous year what are the transactions, they will analyze all the transactions. Okay, yes, year by year is it business growing or growing or not, they have to analyze this. Suppose if transactions are not growing here, suppose last year, suppose this month, yes, December month, suppose last year December month, last year same December month, maybe 10,000 transactions were happened, assume that. Suppose 1,000, yes, 10,000 transactions were happened here. This year, yes, meeting 10,000 transactions or not. Okay, they have to compare this. Okay, same December month 2017, how many transactions were happened here? 2018, how many happened here? 2019, how many happened? Like this, maybe some companies wanted to analyze from the beginning, right? Yes, 2000 year, December month, how many? 2001 December month, 2002 December month, 2003, 2004, up to this, right? Every year December month they should analyze transaction, right? Okay, so whether business is growing or, yes, yes, whether business is growing or not, they have to analyze that, right? Every transaction they should analyze this. Okay, let us take Durgasoft. Let us take Durgasoft here. Best example is Durgasoft. In Durgasoft many students are coming, right? Okay, every year many students are coming. Last year how many students, this year how many students? Okay, suppose last year Jan month this much of students, February this much, March this much, April this much, like this, monthly wise they will maintain data, monthly wise, right? Monthly wise report, right? Okay, yes. So based on, yes, this year Jan month, how many students expecting here? Based on the history, right? Yes, based on last 3-4 years history, they will estimate this. Yes, how many students are expecting this year? Okay, Jan month, how many students expecting? February month, how many? March month, how many? April month, May month. So expectations, right? How they can predict? Yes, that is analysis, prediction. Okay, how they can predict here? Based on the history here. Based on history, they can predict, right? Okay, yes, if expecting more students here, based on students here, they have to provide infrastructure. They should make the arrangements, right? So for this purpose, yes, yes, they should get, they should provide the services for the demand, right? As per demand they will provide services, right? Okay, so based on what business analysis, they should analyze this. So they should analyze this. So last 10 years of transactions or 15 years of transactions, everything should be analyzed, right? Okay, yes. Now here some company their business started 2000 year. Okay, yes, now they wanted to analyze their business. They wanted to, that company wanted to analyze their business. How they can analyze the business here? They will depends on that complete historical data, right? Complete historical data. So how they can analyze that historical data? How they can analyze? See, 2019, yes, these 3 years in live, this data in live. So live data they can analyze, it's in live. Okay, next, previous year's data. Okay, previous year's data. Now here servers current capacity only 3 years of data, right? Current capacity only 3 years of data. Okay, yes, they wanted to analyze this all years of data. Yes, all these years of data get into servers, right? Okay, suppose for example here, let us take servers. There are 100 servers, companies having 100 servers. There are 100 servers, 100 servers. Okay, 100 servers of capacity, 100 servers of capacity. Yes, about 10 petabytes of data or 100 petabytes of data. Okay, yes, there are 100 servers of capacity, 100 petabytes. Okay, yes, to analyze the all this year data here, all these years of data here. So they should, so they should get into this new server, right? Yes, 100 servers. Okay, now 100 servers in live, 100 servers in live here. Yes, all this whole data, that whole data is a backup data, right? All this big backup data. Yes, all this backup data has to store into the servers, right? Should get into live here. So 2000 year data, yes, 2000 year data, backup data has to store into, yes, yes, 2000 year data has to store into that live servers. Next, yes, next 2001, next 2002, next 2003, next 2004, like this every year data should get into live, right? So live, yes, live servers. Okay, so simply, yes, back to live servers, right? Yes, all this data in backups. So 2000 year data, 2001, 2003, 4, like this, right? Like this up to, yes, maybe, yes, up to 2010 here, 2010. Yes, up to, after getting data into, yes, up to this two, yes, 10 years of data. This 10 years of data after getting into servers, suppose servers may become full, servers becomes full. Yes, now currently servers capacity is only 100 petabytes of data. Yes, all the 10 years of data getting into servers, right? Getting the servers. Still, how many years of data? 9 years of data is right. 10 years of data, 10 years of backup data taken into live servers. Okay, just assume that these all 10 years of totally 20, almost 20 years of data, right? 19 years of data. Yes, 19 years of data. Yes, out of 19 years, after getting 10 years of data in live servers, servers may become full, right? Okay, servers may become full. Okay, space is not available. Okay, that means they are facing big data problem out here. Okay, that data, that historical data, they wanted to analyze all the historical data, right? That historical data, total data is more than the capacity of the servers. Okay, their servers capacity is only 100 petabytes, but historical data, all the historical data getting into live, it's not easy. It's all the data getting into live, and they will go for analysis, right? Okay, so what happens is that data, that historical data is more than the capacity of servers. Okay, that means big data, this is called as big data. So they are facing big data problem, right? They want to get, they want to get all these years data, that 20 years of 2000 to 2019, right? All the years of data they want to get into servers. Okay, how they can get it here? Is it possible? No, it's not possible. Reason is that capacity is less, right? Only 3 years of data capacity here. Yes, company storage capacity only 3 years, but they want to get it 20 years of data into servers. It's not possible. Means big data, that means they are facing big data problem. So historical data, so historical data is one of the examples of big data. To analyze the historical data, all this data come to live servers. So come to live. Okay, but it's not possible here. Okay, that means they are facing big data problem. So this is one of the big data examples here. So historical data is a big data. Yes, all data cannot be stored into live servers. Live servers capacity is only 100 petabytes, but 20 years of data means more than 100 petabytes, maybe 1000 petabytes or 2000 petabytes of data. That much of data cannot get into live. so cannot get in live, means they are facing a big data problem. Okay, this is one of the example of big data, one of the examples of big data, right? Okay, yes, this is my practical experience, historical data. Yes, historical data. Yes, when I'm working with yes Diebold company, Diebold company. Yes, they started analyzing their business for the purpose of the analyzing their business here. Yes, all the backup data they have is tried. They tried to store into live servers, but live servers, yes, but live servers not in a position to store all the data. So they have faced a big data problem that time. Yes, in 2012. Yes, in the year 2012, in the year 2012, in the year 2012, the Diebold company started their big data analysis. Okay, data, that business analysis. For that purpose, all that historical data, yes, they tried to store into live servers, but live servers capacity is less than the historical data. So that time started facing big data problem with historical data. Yes, I have seen practically. Yes, I have seen that practical, that experience. Okay, I have seen practically. Okay, so that time yes faced big data problem because that time I was working with data center. Okay, so to overcome that scenario here, they have started working with Hadoop. Yes, we have started working with Hadoop here. So because of my Java experience, started working with Hadoop. Java experience and data center experience. With that experience, started with Hadoop. Okay, started working with Hadoop. Right? Okay. So historical data is one of the examples. Okay. So this is about historical data. So historical data means lot of data, petabytes of data, right? So this is one of the examples of big data. Okay. Next, other examples. Yes, other examples, black box data. Of course, yesterday we have discussed black box data. One more example is black box data. Black box data. Yes, exactly what is black box? Yes, it's a component of aeroplane, right? Flights, data recorder. Yes, it's a data recorder. Data recorder. So data recorder in the flights. Okay, in the flights, data recorder. Okay, it's a data recorder here. Black box. Yes, black box is a data recorder in the flights. Okay, data recorder in the flights. Okay, right? Yes, here black box, it will record everything here, everything, like what are the, yes, what are the conversation between flight crew members. Crew means staff, flight staff members. Yes, flight staff. Yes, every flight, every aeroplane, there are three pilots. First pilot is a first officer, as well as calling captain. First pilot is the captain or first officer. Second pilot is a second officer. Third pilot is a third officer, like this. Okay, captain, second officer, third officer, next supervisor, mechanical engineer, and air hostess, like this. So all the crew, right? So whatever the conversation between crew members, all this conversation recording by the black box. Okay, so not only conversation here, yes, information about the flight, information like time of starting flight, time of destination of the flight here. Next, what's the altitude? Yes, what is current altitude? Okay, how much height flight is flying here, altitude of the flight here. Okay, altitude. Next, what's the direction of the flight is moving here, direction of the flight here. Okay, right? Next, what's a is a fuel capacity, what's a current fuel. Next, weather information. Okay, all that information recording by the black box. Okay, yes, sometimes captain talking to ATC, air traffic controlling system. Every airport there's a ATC, right? Yes, before landing at airport, that captain, yes, should get the confirmation from the ATC here. Once once ATC, yes, once ATC, yes, given permission, they can land into airport. Otherwise, they can't land here. Yes, ATC has to clear the route. Once route is cleared here, if route is available, then ATC give the clearance. So once given clearance here, they can land into airport, right? Yes, even that conversion also will be recorded by the black box. Okay, right? So like this here, black box, it will generate 20 GB data per hour. Okay, 20 GB data per hour. Like this, how many hours? So one flight, suppose, yes, simply here Hyderabad to Chicago. For example, here Hyderabad to Chicago. Okay, yes, Chicago, our data center. We have 3 data centers. Our company has 3 data centers. Okay, main data center is at Chicago. Okay, Hyderabad to Chicago. Yes, maybe taken for yes, 36 hours. Yes, next going there and coming back, totally 80 hours. 36 and 36, 72 plus 8 hours delay, something like this. So totally 80 hours. So 80 hours. Yes, how much data generates here? 80 multiplied by 20, right? So this value is equal to 1600. Yes, GB data. So one flight, yes, a flight in a travel. Okay, so in a travel, it will generate 1600 GB data, right? In a one travel, 1600 GB data. Yes, in a month, how many travels? Maybe maximum 10 travels. In a month, 10 travels, right? 10 travels. So 10 travels equal to 1600. Yes, into 10, right? Multiplied by 10. So that value is equal to 16,000. Yes, 16,000 GB, right? 16,000 GB. This is equal to 1600. Sorry, 16,000 GB is equal to 16 TB, right? 16 terabytes. Okay, so one flight generating 16 terabytes of data per month, right? Per month. Suppose if it is here 16 into 12, right? 16 into 12. This is for only one flight. Yes, see the British Airways. British Airways, they are having 200 flights, more than 200 flights. 200 flights. Okay, more than 200 flights, right? British Airways. 1 second. Yeah. Yes, British Airways. Yes, they have, yes, more than 200 flights. More than 200 flights they are running, right? Then how much data generating, right? Yes, they should keep all the data, right? Okay, so this is big data. Yes, lot of data generating every day by the different flights. So this is one more example of big data. Okay, right? Yes, let us see one more example. Yes, social network sites. Social network sites. Sites like IoT data. IoT means Internet of Things. Okay. Yes. Any data generating in the internet, that is called IoT data. Okay. Yes. Any data, yes, through the internet generating, any data generating through the internet, that is called as IoT, Internet of Things. Yes. What is Internet of Things? Yes. Anything which is running on the internet called as IoT. This is very simple. Anything which is running on the internet is a IoT. Suppose Facebook comes under IoT, right? Yes, Facebook is IoT. Okay, is running in the internet, right? Yes, Flipkart. Yes, all these sites which are running on the internet, internet-based applications are IoT applications. Okay, Internet of Things. Okay, internet-based applications are IoT applications. Okay, they are generating lot of data, right? For example, Facebook. Yes, Facebook generating some data. Facebook. Yes, Facebook generating 4 petabytes of data every day per day. This is Facebook generating 4 petabytes of data per day. Okay. Yes, Facebook generating 4 petabytes of data per day. Next, see YouTube. Similar YouTube. Yes, YouTube. Yes, YouTube generating, yes, many hours of data per day, right? Per day, lot of data generating here. Yes, YouTube. This is 2 TB data generating per day here. YouTube, 2 TB data generating per day. Sorry, not 2 TB. Sorry, 6 TB data. 6 TB data. Facebook is 4 petabytes. Okay, YouTube is 6 TB. Okay, yes, what is petabytes? What is terabytes? Yes, I think yesterday we had discussed something about this. See, yes, 1 byte equal to 8 bits. 1 byte equal to 8 bits. Yes, next 1 KB. 1 KB equal to 1024 bytes. Okay, 1 KB equal to 1024 bytes. Next after this 1 MB. 1 MB equal to 1024 KB. Okay, next 1 GB. After this 1 GB equal to 1024 MB. Yes, this you should remember always. Most important concept in big data, not only big data, in software itself. Every software guy has to, yes, remember this one here. You must have this idea. Yes, 1 byte equal to how many bits, 1 KB equal to how much, 1 MB equal to how much, 1 GB equal to how much. Okay, yes, after GB next is terabytes. So 1 terabytes equal to 1024 gigabytes. Of course, yesterday we have discussed, still repeating because some new members are there. So 1 terabytes, yes, yes, after terabytes next is petabytes. 1 petabyte equal to 1024 terabytes. Okay, after petabytes, exabytes. Okay, exabytes, yes, 1024 petabytes. Okay, next after exabytes, next zettabytes. 1 zettabyte equal to 1024, yes, exabyte, right? This is okay. See, in this, up to GBs, is a small data. Up to GB small data. From terabytes to zettabytes, from terabytes to zettabytes. Okay, terabytes to zettabytes comes under big data. So this is from this terabytes onwards, it's a big data. So this range is a big data. From this onwards is a big data. Big data, right? Okay, yes, I will tell you one example. 1 terabyte, yes, 1 terabyte means how much data? Let us see some example. Take movie. Let us take one movie here. So what is size of a movie here? Size of a movie. Okay, size of a movie. So size of one movie is equal to maximum 3 GB, right? Maximum 3 GB. Okay, size of movie is equal to, so 3 GB, right? Okay, yes, 1 terabyte equal to how many movies? Yes, 1 terabyte is equal to how many movies? Okay, so here size of movie 3 GB, right? Yeah, 3 GB. Yes, next, yes, 1 TB. See, 1 TB is equal to 1024 MB, right? Okay, yes, sorry, GB. Yes, 1024 GB, right? 1 TB equal to 1024 GB, right? That means how many movies? This is equivalent to, yes, 1024 by 3 GB, right? Okay, so 1024 divided by 3 GB here. So 1024, yes, 1024 divided by 3. Yes, this value is equal to almost to 300, right? Yes, 300, not 300, 350, around 350. Okay, yes, around yeah, 341. Okay, fine, 341, right? This value is equal to 341, means 1 TB equal to 341 movies, right? So 1 TB data is equal to now 341 movies. Now you can imagine, right? Yeah, this is very easy to understand here. Okay, one movie size is 3 GB generally here. So 1 TB data means 341 movies, right? You see, in Facebook, how much data generating here? In Facebook, how much data generating here? 4 petabytes of data. 4 petabytes means, you can imagine. Okay, 4 petabytes. Yes, what is 4 petabytes here? 4 petabytes equal to 4 into 1024, right? 1024 terabytes, right? Okay, terabytes. So this is divided by 3. Divided by 3, right? Yes, how many movies? 4 petabytes. 4 petabytes. Okay, so here, see, here 1 TB data. So this is 1 TB data, 341, right? Now 4 petabytes means 4 into 1024, right? 4 in 1024. So divide by 3. So this value 1364. Okay, fine. 1364, right? Means that much of movies, right? That much of movies. Many number of movies, right? So this is big data. Yes, try to analyze like this. Okay, what is TB, what is petabytes, what is exabyte, what is zettabyte? Try to analyze like this. Okay, so here 4 petabytes of data means almost 1364 movies we can store, right? That is 4 petabytes. So this much of data, 1300 movies of data generating in the Facebook every day, means lot of data, right? Lot of data generating every day here. Okay, so this is one of the best example of big data here. Social network sites, Facebook, YouTube, okay, next Twitter, Okay, next Google. Okay, like this, different kind of things, right? So they are generating lot of data every day. Okay, next, one more best example is, yes, Google search engines data. Search engine, search engines data, search engines data, Google, Google data, right? Yes, Google, yes, in Google, yes, in Google every day, yes, 3.5 millions of searches happening here. Millions of searches, 3.5 millions of searches happening every day. 1 million equal to 10 lakhs. 3.5 millions means what? 35 lakhs of 35 lakhs of searches. Okay, generally here in US they will call as millions, they don't know lakhs. Yes, we are calling 1 lakh, 2 lakh, 3 lakh, 10 lakhs, right? But in US they don't have about lakhs. Okay, they don't have lakhs like this. Okay, yes, so they will call millions. Ones, tens, thousands, after thousand they will go for millions. Okay, usually Indians are lakhs. Ones, yes, one, 10,000, 10,000, and 1 lakh, right? 10 lakhs, 1 crore. That is our measurements. But as per USA, 1, 10, yes, 1,000, yes, and after 1,000, then it's a million. Okay, million, next billions and trillions. Their measurements are like this. Okay, so 3.5 millions are happening. That means 35 lakhs, 35 lakhs of searches happen in Google here. So a lot of data generating. This is one more example of this. Like this, we can discuss many number of examples. Okay, many number of examples. Okay, power grid data. Similarly, power grid data, right? Power grid data. Okay, yes, every consumer, yes, every consumer information they should maintain this, right? Okay, power grid data. Okay, next, one more example, stock exchange data. Best example is stock exchange data. Stock exchange, stock exchange data. This is also one of the best example. Okay, yes, no 10,000 concept in US. Okay, yes, yes, next, stock exchange data. Yes, what is stock exchange data? See, in stock exchange every day some transactions happening, right? Some every day some transactions are happening here. Okay, yes, suppose, yes, buying some shares. Directly we can't buy the shares, right? By seeing history we can buy the shares, right? Maybe last 3 years of history, last 4 years of history, right? Maybe somebody considering last 10 years. Means stock exchange, maybe New York Stock Exchange or maybe Mumbai Stock Exchange, they should maintain all the 10 years of data, right? 10 years of data is not easy. 10 years of transactions is not easy. So big data they have to maintain, right? Yes, if it is big data, lot of storage capacity required, right? Okay, main problem with big data, storage. Storage is the main problem. Okay, if the problems we'll discuss, just wait. So stock exchange data, right? This is one more example. Okay, so stock exchange, in stock exchange maybe 10 years of data, 20 years of data they should maintain this is. So because every share history they have to maintain this is. Okay, so this is one more example of this. Next, like one more example, yes, telecom data. Telecom data. Okay, telecom data, right? Yes, all the examples. Okay, next, banking data. Okay, telecom data, banking data. Next, medical data. Okay, medical data also one of the best example. Okay, so these all the examples of big data. Like this we can discuss many number of examples. Okay, so this is just idea about big data. What is big data? I think everyone clear, right? Yes, I think you got some idea about big data, right? Hello guys, I think you got some idea about big data. So
Yes,
this
sir.
is big data. Just idea about big data, right? Yes, going forward we'll discuss many number of concepts in big data. This is just only introduction. Only introduction. This what is big data? This is just only introduction. Yes, you'll see practically. Going forward we'll discuss practically. Okay. This is one of the examples of big data. Okay, right? Okay. Yes. Next, with big data, there are a lot of challenges. Yes, traditional systems, traditional databases like Oracle database, maybe MySQL database server, maybe Microsoft SQL server, maybe IBM DB2. Like that, we have many number of database servers, right? These all traditional databases. These traditional databases are not in a position to store that much of data. There are many challenges we have to face from the big data. Yes, what are the challenges? Yes, we have faced practically. Yes, with the D World company. Yes, in 2012, in D World company. Yes, in D World that company. In that company, we have faced. It's a my practical experience. I have seen it live. Okay, we have faced some big data problems. Okay, because of that, we have started working on Hadoop. Okay, D World it's a very big company. It's ATM machines manufacturing company. ATM machines. Yes, D World it's ATM machines manufacturing company. Yes, ATM machines. Yes, we have the clients more than 160 countries. Many countries. We have the clients. We have the customers. So lot of data is generating, lot of transactions happening every day. So we faced the big data problem in 2012. Practically, I have seen this is okay. Yes, it's live. Yes, I have the live experience with big data. Okay. Yes, yes. To face that problems, yes, we have started working with Hadoop. Yes, what are the challenges? What are the challenges that can be faced from the big data here? Let us see big data challenges. Big data challenges.
Sir, I
Big
have a
data.
small doubt.
Yeah, tell me.
Sir, what is traditional database?
Traditional database. Okay, I'll tell you. Traditional means, see, traditional softwares like Java is a traditional software, right? Because since last 20 years, what are the softwares we are using since last 20 years? Those are traditional softwares. Java is a traditional software. C is a traditional software. .NET is a traditional software. These all are traditional softwares. But Hadoop is not a traditional software, right? Recent this is Hadoop. Okay, Spark and Scala, AWS, DevOps. These are recent softwares. These are not traditional. So old softwares all are traditional softwares. Now, what are the traditional databases? Traditional database since last 20 years we are using some database, right? Like Oracle database, like Microsoft SQL Server, like DB2, MySQL. Since last 20 to 20 years we are using these databases. These are the traditional databases, traditional things. Traditionally we are using, right? I think you understand, right? Okay, so this is traditional. These are traditional databases. Okay, so since last 20 years, whatever the softwares we are using, those are called as traditional softwares. Java is a traditional software. Okay, but Hadoop is not a traditional software. Hadoop is different. Okay, yes, yeah, all database servers, almost all database servers are traditional database servers. Okay, all database servers, every database server is a traditional database server. Okay, right? Yes, latest servers like MongoDB, those are column-oriented database servers. Those are not traditional. That is different. All old servers, old database servers, all are traditional systems. All are traditional systems. Right? Okay. Yes. Now, big data challenges. What are the challenges with big data here? Okay, first challenge, main challenge with big data, main challenge with big data is data storage. Data storage. Main problem is data storage. Okay, so main problem with big data is data storage. Okay, yes. Next challenge, data storage. Next, data processing, right? Suppose small amount of data means easy to process. If it is small amount of data, easy to process, right? But big data is not easy to process. Suppose 100 GB easy to process, but 100 terabytes of data is not easy to process, right? Data processing, that maybe data transferring from one location to another location, maybe filtering data. Suppose there are, yes, billions of records. Yes, I want to filter that records. Okay, based on salary or based on some date, how we can filter? Okay, if it is 10,000 records, if it is 10,000 records, easy to filter, right? 1 millions of records also easy, but billions of records is not easy to filter, right? Okay, the data processing time taken, right? Okay, so next challenge is data processing. Data processing. Data processing is the another challenge. Okay, so first data storage, next data processing. Data processing is another challenge with this big data. Data storage, data processing. It's not easy to process data. It will take lot of time. Okay, yes, next, third one. Yes, data storage, data processing. Next, with big data, high-end hardware required, right? What is high-end hardware? We'll discuss. Just wait. Yes, high-end hardware required. Okay, high-end hardware required. Okay, yes, high-end hardware required. Yes, high-end hardware required. Low-end hardware is enough. Low memory space is not enough, right? High-end hardware required. High-speed processors, high amount of memory space required, right? High-end hardware. Okay, so high-end hardware required for the big data. Okay, if it is small data, we can go for the low-end. Okay, but if it is big data, high-end hardware required. Okay, yes, next. Yes, next apart from these other challenges, yes, large files, large files. Yes, with big data, there is a chance of generating very large files. Suppose, for example, here some transactions. Let us take some transactions. Suppose take some application. Take some application. Okay. Yes, take some application. Suppose application is running from since last 10 years. Some application generating, sorry, some application running since last 10 years. That application generating log file. Suppose the application generating some log file. Okay, that application generating some log file. Okay, yes, based on transactions generating some log file. Suppose that application started in the year 2010. Yes, 2010. Okay, suppose monthly one log file. Yes, in the year 2010. Yes, that log file size may be 1 GB. 1 GB, right? Okay, yes, next year transactions increasing, right? When transaction increasing, automatic log file size also will increase here. So next year maybe 10 GB, right? Okay, so only one file maintained for monthly one log file, right? Monthly one log file. Yes, 2010. Yes, next year. Yes, 2010 is 1 GB. Next year maybe 10 GB. Next year maybe, yes, maybe 30 GB, because of transactions increasing, the log file size increasing, right? Okay, yes, transactions increasing, automatic data increasing here. Okay, so the log file size increasing automatically, right? If the number of transactions are more, log file also size increases, right? Okay, like this goes on increasing like this, right? At some stage maybe chance of generating 1 TB terabytes of log file also. Okay, yes, it's a very big data file. Yes, large files. Yes, our traditional, yes, file systems like Linux and Windows, these are traditional file systems. These traditional file systems are not in a position to handle 1 TB data file. Okay, Linux or Windows, they can handle only just hundreds of GB data. That's it here, not terabytes of data. Maybe 100 GB data can handle, maybe 200 GB data can handle, but 1 TB data cannot handle here. Okay, right? I think yes, we'll not see anywhere, right? Okay, have you seen anywhere? Yes, 1 TB data file with Windows Linux, no chance, no chance. Okay, so large files. Yes, our traditional systems cannot handle large files. There is a chance of generating large files. Okay, so this is one more challenge with big data here. Okay, data storage, data processing, high-end hardware. Next, very large files. There is a chance of generating very, yes, very large files, very large files. So this is fourth one, right? Okay, next, fifth one, yes, backup backup and recovery, backup and recovery. So backup and recovery, yes. So here, if it is yes, in traditional database, every day we should take the backup, right? Yes, it's not easy to take the backup here. So sometimes backup may be failing. Okay, maybe incremental backup, fully backup, something like this. Okay, so maybe sometimes backup failing, right? Yes, okay, any issues raised here, they should fix that issues. They restart the backup, right? Okay, next, recovery. Suppose any server crashed, then recover, right? What is recovery process? I'll tell you step by step. Recovery process, any database server crashed, yes, how to recover the database? There are many stages. Okay, many teams have to involve this. How many stages in recovery? Yes, tomorrow I'll explain that. Backup and recovery concepts. Okay, very important, real time here. Yes, recovery, how to recover these servers. Sometimes total data center may be crashing. Okay, how to recover total data center? Okay, that complete topic we will discuss. Okay, yes, next, so backup and recovery. Next, sixth one is, yes, disaster. Yes, disaster management. Disaster management. Disaster management. This is called DR act. Disaster recovery. Disaster recovery. Okay. DR activity. Okay. Yes. Disaster recovery. Yes. Disaster recovery. Yes. Disaster activity. Okay. Yes, I had a good experience with disaster activity. Yes, I will tell you. Yes, how they can recover from data center. Any data center crashed here, how they can recover. I will explain very clearly. DR activity. Yes, 4 times I was involved with DR activity in our company. Okay, what is exactly DR activity? Yes, 4 times. 4 times I was involved in DR activity. So how to perform DR activity? I will explain this is. What is purpose of DR activity? We'll discuss. I'll explain very clearly this is. Okay. Yes, disaster management. How to manage that? Okay. So these are these are the main challenges. These are the main challenges. Yes, apart from this, other challenges. Okay, like capturing data. Okay, transferring data like this, different kind of things. Many kind of things are there. These are main. So these are primary challenges. Okay, just
Sir, I have
these are
small
the
doubt.
primary challenges. Examples are given. These are the primary challenges. Yes, what is data storage? We have to discuss, not to discuss this point here. Yes, I should discuss about data storage point. Yes, about each and every point I should discuss. Okay, data storage. So what is the challenge facing the data storage? Okay, yes, what is the challenge data processing here? What is high-end hardware? What is large file? What is backup and recovery? What is disaster management? I should explain. Just I have given the list of these challenges. It's a list, not yet completed. Okay, tomorrow we'll be discussing very clearly each and every topic. Data storage, what kind of challenge from the data storage? What kind of problem from the data processing? Next, what kind of problem with the high-end hardwares? Okay, next, very large files. What kind of problem with very large files? Yes, all things. What is exactly backup? Okay, how to take the backup care? Who will take the backup care? Okay, backup scripts. Okay, next, recovery. What is recovery process? Step by step I have to explain here. I should explain each and everything here. Just a list of challenges given. This one list is given, not yet explained here. Tomorrow we'll be discussing about all these challenges, right? Okay, yes. Till now what I discussed, same topic yesterday we discussed, same topic just repeated. Today same topic just repeated. Yesterday also same topic discussed. Apart from this, yes, nothing extra discussed here. Same topic repeated here. Tomorrow I'm not going to repeat same topic again. So today somebody joined, some new members. So because of some new members, yesterday topic completely repeated. Nothing leaving yesterday here. Yes, every topic, nothing left, every topic covered. Even extra topics also explained today here. Some today extra concepts also explained here. Okay, yes. So tomorrow I'm not going to repeat same topic again here. Tomorrow I'll be entering this big data challenge. Each and every topic I'll explain very clearly. Okay, then yes, here to face all these big data challenges in market, Hadoop is the best technology. Yes, Hadoop is the best solution to face all the challenges. Okay, Hadoop is the right technology to face all the challenges. Okay, yes, here, yes, data to in traditional system, what's the problem? Yes, that problem how to face using Hadoop. Okay, in traditional system data storage problem, yes, how to overcome using Hadoop. Okay, next, data processing in traditional system, data processing problems, right? That problems how to overcome with Hadoop. Okay, next, high-end hardware in traditional systems, high-end hardware required, but in Hadoop high-end hardware not required. Okay, how it is, that we'll discuss with Hadoop. Okay, very large files, traditional systems are not in a position to handle large files. Then Hadoop can handle large files. How it can handle large files? Okay, next, backup and recovery. Yes, in traditional systems backup required. Yes, in Hadoop backup is not required. Next, in traditional systems recovery required, but in Hadoop recovery is not required. Next, DR activity. Yes, in traditional systems compulsory DR activity required, but in Hadoop not required. Okay, Hadoop manage everything. How it will manage everything, we'll see. Yes, tomorrow topic is traditional systems versus Yes, Hadoop here. Traditional. Yes, traditional systems versus Hadoop tomorrow topic. Okay. Yes, tomorrow topic traditional systems versus Hadoop. Okay. Yes, for this purpose, yes, Hadoop in Hadoop, HDFS and MapReduce. Little bit I'll explain about HDFS and MapReduce. After that, I'll compare this traditional systems versus Hadoop here. Okay. Yes, all these challenges we can face using Hadoop. How we can face? Okay, how Hadoop provides solution? Yes, what's the solution from the Hadoop? What is solution from the Hadoop to face all the challenges? Tomorrow we are going to discuss. Okay, so traditional systems versus Hadoop tomorrow topic here, right? Okay, yes. Any doubts for today? Yes, guys. Yes, today topic. Any doubts? No doubts? Yeah, 1 second. Someone is asking doubts. If internet speed is equal to the data storage capacity, then data processing will solve. No, internet speed and data storage both are not related things here. Data storage means your servers. Yes, your servers capacity plus your servers processing speed. Okay, data processing always depends on your servers and yes, data storage servers and data servers speed of the processors, not depending on the internet. Okay, only data transferring from one location to another location is internet, but data has to process inside of the servers, right? To process data inside the servers, that depends on servers capacity, servers processing speed. Okay, same exactly tomorrow I'm going to explain data storage, data processing. Tomorrow will be discussed with data storage and data processing. Okay, yeah, definitely. Yes, Hadoop jobs is working for data center. See, data center maintenance is different. Yes, Hadoop jobs are different. Hadoop jobs are to handle and process data. Yes, Hadoop jobs are to develop the applications to process the data inside of data center. Data center maintenance is admin guys. Okay, storage and processing purpose Hadoop requires. So that case, in that case, Hadoop developers, Hadoop admins are required. Okay, yes, I'll tell you exactly what are the roles of Hadoop in the industry. Role of Hadoop in the industry we'll discuss. Okay, yes, we have separate topic and this I'll explain very clearly. Okay, yes, goes on each and every topic will be cleared. Okay, right? Yes, why kept the elephant icon on Hadoop? Reason is, see, Hadoop, yes, actually it's a toy, elephant toy. Okay, it's in, yes, toy is a elephant toy. Yes, same that toy given for the Hadoop that history will discuss. Okay, who is the developer of Hadoop here? So why named as Hadoop? Okay, there is a Hadoop that elephant a toy name. Hadoop exact name is elephant a toy name. Okay, so why name given as Hadoop that history? Yes, we'll discuss. Wait. Okay, definitely I'll explain it. Just wait for 1 day. One more day, I'll explain that history. Okay. Yes, every topic I have prepared in document, so you don't worry about documentation and all these things. Okay, this notepad, if you want this notepad, I can send these notepads also. What are the topic explain notepad? I'll send you. I'll email you for every guys. Yes, for all of the guys, I email this notepad. Not a notepad here. I have prepared documentation. Yes, I'll show one document. Yes, Hadoop document. Yes, print material. Yes, course contents or the core modules. This is core modules. Yes, this is around 180 page document. This is 180 page, around 180 pages. What is big data? Big data definition. Yes, what are we discussed today topic? Okay, historical data, black box data, social media data, and all these things. Till now, what are discussed here? Today topic is a document here. So everything is there in documents. Big data challenges. Okay, yes, major challenges: data storage, data processing, very large files, high-end hardware, like this, all things. Okay, next other challenges: data analysis, data transfer, sharing, searching, capturing, presentation, all this. Okay, yes, what is traditional approach? Tomorrow topic this is traditional approach. Next, what is Google approach? Google approach is nothing but Hadoop. Yes, Hadoop, it was developed by the Google. At the beginning, started by the Google here. Later, it taken over by the Apache. Okay. Yes, Hadoop. What is exactly Hadoop? Okay. Yes, see this. What are roles in the Hadoop? Hadoop architect, Hadoop developer, Hadoop analyst. Yes, that Hadoop admin, tester. They are the roles, different roles. Okay. Next, yes, what is happening in big data in Hadoop projects? So this one. Next, suppose you take any business, what is life cycle of business? What is data generating in the business? Like yes, purchasing department, stores department, raw material, like this, something like this. It's very, yes, large scale industry. Some enterprise. One enterprise, in enterprise, what are the transactions happening here? What is the data generating? That all is I have prepared very clear documents. Okay. Yes, 3 V's of the big data: structured data, semi-structured data, unstructured data. Next, yes, OLAP, OLTP, those things. Okay. Yes, all of these things prepared in documents. Everything that Hadoop history. Okay. Hadoop history. Okay. Yes, why that elephant name? Okay. Yes, that we'll discuss. Yes, in history of Hadoop. That time I'll explain it. Okay. Yes, we'll continue tomorrow. Yes, for every topic I have prepared. Yeah, Hadoop, yes, is not related to cloud. Yes, on cloud, yes, we can install Linux OS. On top of Linux, we can install Hadoop. Okay, cloud and Hadoop, that relationship I will explain. Okay, clearly I'll explain it. Okay, right? Yeah. So for everyone, this is only core modules. In the remaining all the modules, remaining ecosystems, we have other documents. Okay. Yes, I think around 1500 page document I have prepared. Okay. So don't, yes, see data center. This is our data center photograph. Our data center this is. Hadoop cluster architecture. Okay, 1.x version, 2.x version, every architecture, 3.x, all these architectures explained very clearly prepared documents. Okay, on each and every topic. This is my experience. It's not copied from anywhere. With my experience, I have prepared all this documentation. Okay, Hadoop commands and everything prepared here. Okay, all of these things. Yes, how MapReduce is working. This is about MapReduce. Like this, all is step by step developing MapReduce. Okay, Linux. In Linux, we are going to, yes, work on Hadoop, not Windows OS. Okay, so because just only these demo topics explain Windows here. Next, I'll be moving to Linux. Okay, tomorrow or day after tomorrow, I'll be moved to Linux OS. Okay, yeah. So this is the document. In document, everything explained very clearly. So see this comparison 1.x and 2.x version comparison here. Like this, all the things. Everyone 1.x architecture, 2.x architecture, yes, both explains very clear explained documentation. Okay, all of these things. Clear document is there. Okay, next yarn concepts and all these concepts very clearly explains. Yes, these are around 162 page documented. Okay, next 1.x and 2.x ecosystems. This last topic, final topic. Yes, all the things explained very clearly. Right? Okay. Yes. Next, someone is asking doubts. Yeah, payment gateways. Yes, we can use servlets. Yes, Java applications, payment gateways. Almost all payment gateways are developed in Java applications. Okay, but Spring framework not. exactly, it's not servlets. Using Spring framework. In framework, we have that kind of facility. Okay, right? Yeah, yeah. Thank you, guys. Yes, I think no doubts for today, right? Yeah, Spring, mainly Spring applications, Spring framework applications, using payment gates and all these things, Spring applications, Java Spring applications. Okay, right, guys? Yes, tomorrow we'll continue. Yes, tomorrow we'll discuss about Hadoop. Yes, about Hadoop versus traditional system. Tomorrow topic, right? Okay. Yeah, thank you, guys. See you tomorrow. See you tomorrow. Right? Have a great day.